I splurged on one of these ring squaring tools. Should work for multiple bores. All these ring gaps are really close. The machinist did it. He's probably got a way better tool than I have. I've done a calculation of my ring gap. I know what I'm looking for. We're gonna see what we got here. It's my understanding this chart's a little on the conservative side. I don't know if they had to shorten these up or not, but all these top ring, this is like the filler for the gapless. The gaps are all about the same as the top rings. Yeah, this thing goes from 4 to 423. I've come to the conclusion that it's worth it. Checking all these oil scraper rings, and it's just calling for 15 thousandths minimum. All my clearances are written down, and I'm gonna make a nice printout of this when I'm all done. So if I rip this engine apart, I got something to reference. So this wrist pin is so far up, it has a void for the oil rail support. So they have an oil rail support ring. There's a little bump in there that keeps it from rotating. The rest of this is just like a regular ring install. The expansion ring. Oil scraper. The Napier ring, I think that's how you pronounce it. The machine bits in the bottom and then dot up. Trying to scratch my piston up too much here. We got our top ring with that groove down. And then like that filler ring. Setting it 1.5 minimum of clearance top to bottom. Stir in the bottom. Stir all the way around. I'm going to position all my ring end gaps as this diagram says. And then I got a 4190 taper ring compressor. And I'm going to see if that works on this. I had a 4185, but that's a bit small for what we're doing here. Well, the first two pistons went right in. Checking rod side clearance, and it's looking good. I realized I don't have a crank bolt, and right now might be a good time to degree the cam without rolling all the rest of that stuff around. So I had to put an order in. I have to wait a couple days here. So I started with just a block here, and had to get all the hardware to put this together. So I decided to try one of these like bronze thrust plates, and I ended up with 2 different sets of bolts to put it on. I checked these, it looks like they're clear just fine. This looks like better grade 8 hardware. It's grade 5 there. So I'm gonna go ahead and bolt this on, and then it actually has an end clearance for me to check. Camshaft end plate 3 to 9 thousandths. Checked everything deburred, looks good. So I'm gonna try this Rollmaster Gold series and then see how this all goes together. The plate's not coming back off, so I'm just gonna put a dab of assembly lube on this thrust surface of this cam.
Everybody's got a story about things that happen that you think, why does this have to happen to me? You know, but everybody goes through it. I've just witnessed a simple job of putting on the timing chain and the cam sprocket. We spent hours because the keyways, Woodruff keys would be working their way back, put the sprocket on all the way, which was not a slip fit, it would go on really tight, and the chain and the sprocket, to get it on all together, has to go at the same time, and you'd be trying to get that cam sprocket on, and the keyway would kick up, and we fiddle fart around, take it apart, clean the keyway edges up so it wouldn't catch. It went on forever. I've never seen anybody have this much trouble just putting on the cam sprocket and the crank sprocket. It was ridiculous. But you see the pistons up top dead center. We got a nice flat top, right zero deck. Roller cam, everything's in time. You can show them the dots. Nice dual roller. Beautiful bolts. Nothing but the best on this. You know, it's all gotta be ARP. They're really expensive bolts.
Here's the damper I'm going to use. This is off the other engine that slipped right on there. And it is not slipping on here. So I don't think the issue is really with the gear. I think it's with the snout of this crank. Slightly a bit big maybe. I may run a hone or something through this. I don't know. When I put the degree wheel on here, if this comes up as perfect, I'm just going to leave this chain on here and dump a bunch of oil over it a couple times before I put the timing chain cover on. It's such a bear to get on there. But I'm going to roll this all over and see if we have any interference issues. That program he had to clearance this may have accounted for some of this stuff. Taking a minute to measure camshaft end play. You're saying 3 to 10 thousandths. So I set up my fixture here. It's all the way back, zeroed out. It's got like 4.5 thousandths, something like that. Well, I was jagging around with this, double checking everything, and this is what I came up with. This is really a small cam for what I'm doing here, and if the wrong person beats me, I'm just going to stick a bigger cam in it. And this motor is going to be set up to take a lot bigger cam than this. But it seems to me all my events are happening late. So I'm going to advance this cam by 2 degrees and then see what that does. I sanded out some of the inside gear, cleaned it out really good. And it's slipping on there easier, but I'm still going to install it with a balancer installer tool. I just had some sandpaper on the end of a screwdriver. Kept running it through there piece after piece. Once again, the timing chain is installed. We got the +2 on the dot. So this is 50 thousandths before max lift. It's about 65. It's 50 thousandths after. That's about 156. So 65 plus 156, 221 divided by 2. It's 110.5. That's a hell of a lot closer to what my intake center line is supposed to be. We'll check the opening and closing events. Just trying to enjoy the whole process here of assembling this engine. That's about 4.5 before top dead center. It's at about 45, I'd say, after bottom dead center. Move this guy to the exhaust now. It's about 56 degrees before bottom dead center. And we'll call that 0 degrees right at top dead center. So here's card and actual. My biggest variance is the center line at 1/2 degree off, and everything else is inside of that. This is with the 2 degree cam advance. Now there's probably some measuring errors in here, but that's just how it goes. This is an 18-inch degree wheel. I almost bought a 24-inch degree wheel for this project. I don't know, for some reason this is like the favorite part of the engine assembly for me. I'm gonna put all this stuff away for now and then get all the rest of the pistons in here, and then we got more boxes coming. I need this eccentric in here for this space we got. Probably gonna put an electric fuel pump in the car. But you see what I planned. I'm gonna put some assembly lube on that. A little Loctite on the bolt. I got one of these ring spreading tools. I'm not using it though. I think this thing's kind of a joke. You gotta spread that ring so far to get it up over the piston. I was watching a video guys saying this is the only way to do it. I just spiraled them all on there. It seems to me that that's the better way. Of course, I'm just an amateur, so take it like a grain of salt. The engine guy got all the radiuses correct, as far as I can tell, for rod direction. So all the pistons and rods are in it. That seemed to go quite well. I got all my side plate checked. That's all good. A lot of parts for the time being. I'm gonna have to order some more stuff. Looking at a special oil pump for this. I really wanted to do a dry sump, but it's a stock crossmember car and don't think that's gonna happen. I put a Sharpie wrong when I was indexing the rings. Just help me keep my place. Got my first soakage of oil on there because not taking this back off, I don't have to. Them short skirts are coming out of them cylinder walls. I wonder how noisy this engine's gonna be. So I think that's gonna be it on this video. I will see you on the next one.